Hi there. In today's video, I'm going to show you how to estimate and interpret cointegration and vector autoregression models. Before I do this in eViews, let me show you what are the various steps involved in it. So, first of all, I would like to check unit root of various series. That is, I will have to determine whether these series are stationary of order 0 or order 1. And then I will select leg length, and after this I will be checking cointegration. If there is cointegration, I will estimate vector error correction mechanism, but if there is no cointegration among the series, in that case I will estimate VAR model. And after estimating my model, I'll be using some diagnostic tests. I'll check autocorrelation LM test, and I will also check White test for heteroscedasticity and normality of the residue. So let me open my data file. This is my data file. Here you can see, and in this file I have different types of variables. Some of the variables are in absolute term. Then I have taken these variables in log term, natural log of these series, and I have also computed growth rate of all those variables, and I can estimate VAR and cointegration in all these different form, and then I will select the best model. But just for the sake of convenience, let me open my those variables which are in log form. So I have log export, log imports, log money supply, log price level, and log real GDP. Let me open these variables as a group. Now these are my variables, and this is quarterly data from 1983 quarter 1 up to 2004 quarter 4. So this is quite a big sample, and the total number of observations are 84. So there are 84 observations in this. So first of all, I will check stationarity of these variables. So let me first start with the Ly. Ly is my dependent variable. That is the natural log of GDP. So this is real GDP. So view, and first I would like to view its graph, and this is the graph of the various variables, and sorry, let me open just one by, I will check this one by one. Let me first okay, this is my Y variable, that is log of real GDP, and this data is from 1983 quarter 1 up to 2004 quarter 4. So first let me check its graph, and the graph may suggest me, in this graph we can see that the data of the log of real GDP shows a positive trend, and there is also intercept. So this data is not stationary, so I will have to correct it. Now let me check the other variable, and that is LP. This is my LP data. Again I will check its graph, and its graph also shows a positive trend. Now I will check the graph of log of money supply. Let me view its graph. So its graph can also suggest, there is also a positive trend, and I think in all these variables there is a, a positive trend in the series. So I will have to correct these data because it may have some positive or negative trend. Now in this case, this is the log of imports, and this one is this is the interest rate, and this has a downward trend. Now let me check the log of export data. This is export data, and I will view its graph, and yeah, this also has a positive trend. So the 5 variables, that is log of real GDP, log of prices, log of money supply, log of imports, log of exports, these have some kind of trends. So these series are not stationary. So I will check stationarity of these, and let me start with the log of Y. So the go to unit rest, and if I check at level with intercept and trend, because there is a trend and intercept, so this is the null hypothesis is that the log of real GDP has a unit root, and its probability is 0.89. So we fail to reject this null hypothesis. So it means that the log of Y is not stationary at 0 or at level. So I will check its stationarity in difference form, the first difference, and I will, yes, now I have corrected for the unit root of the log Y. So if I take first difference of the log of real GDP, then it is stationary. So I will take the first difference. Now let me check the stationarity of the price, and first I will check its stationarity at level, and there was also trend and intercept. So again this shows that there is no unit root in the log of prices. So this one is stationary at level. Now let me check the unit root of money supply. First I will check its money supply in the level, and yes, there is this stationary, this series, that is log of money supply, has a unit root at level. But if I check its unit root at the first difference, then it will become stationary. So again this is not quite stationary, but yes, this is stationary. So when I take the first difference of the log of money supply, then I reject the null hypothesis that it has a unit root at 4%. Sorry, I will also check the log of price level, unit root at level of the log of price. So yeah, the log of price has also a unit root at level. Now I will check its unit root at the first difference, and maybe this will become stationary. Yes, when I take the first difference of the log of prices, then this series becomes stationary, and the p value is much lower than 1%. So this is 0.000. So now let me check for the LI. This is LI, and if I check its unit root at the level, yeah, it's not stationary. But if I check its stationarity at the first difference, maybe it will become stationary. So this is the, yes, now it became stationary, and we reject the null hypothesis that the log of interest rate, when I take its first difference, becomes stationary. Similarly, Similarly, the log of exports, this is the data, and if I check its unit root at level, it may be non-stationary. Yes, it has a unit root because the probability value is 0.81, which is much higher than 0.05, so we fail to reject the null hypothesis. Now let me check its unit root at the first difference, and I hope it will become stationary. Yes, when I take the first difference of log of exports, it becomes stationary. So ladies and gentlemen, I checked unit root of all my variable, that is log of real GDP, log of prices, log of money supply, log of imports, and log of exports, and all these series were having unit root at level, but when I took its their first difference, then they became stationary. So all of the 5 series are stationary at 1, that is they become stationary when I take the first difference. So now I can go for either cointegration or this VAR model. So the next step is to select the leg length. So how to do that? Let me open all my series in a group. So all these 5 series in a group, and then I will estimate. Then I will estimate as a group. So these are my 5 series: log of real GDP, log of prices, log of money supply, log of imports, and log of exports. So let me check for leg length. So first of all, I would like to go for the VAR, estimate VAR, and here I will write the names of my variables, that is ly, lp, lm, li, and le. And by default, this is there are 2 legs, so I don't want to disturb it. Press OK, and this is my vector auto regression estimates. Now these are ly, lp, lm, l1, and le, and these are the other variables in first leg and second leg. So leg 1 and leg 2, all of these variables. So now I will go and check the leg length. So this is leg structure, and go to leg length criteria. So let me write, although this is a quarterly data, so I can either take 4 legs or 8. Let me write 8 and press OK. Now I have this. Now it's up to you, it depends upon your topic, your problem. Now 2 criteria suggest that there is one leg length I should take, and 2 criteria suggest that I should take two legs. So I will let me take 2 legs instead of 1. I may take 2 legs. Now I will go for cointegration. So quick group statistics, and here is a cointegration, and in cointegration my variables are there, and here I will write leg length interval, so I will write 2, and I will just keep this checked, this number 3, intercept and no trend in cointegration and test VAR. Press OK. Now just a minute, group statistics, Johansson cointegration tests, and yes, I will keep this 2 as my leg, because I use Akaike information criteria and one other, so I just use 2 legs. So press OK, and this is yes. Now this is my estimated cointegration equation. Now you see these are the series, and the lag intervals are in first difference is 1 to 2. Now unrestricted cointegration rank test is this, and I can decide either using trace statistic or using max eigen statistic. So let me first use trace statistic. Now this none shows that my null hypothesis that there is no co-integrating equation, and if I check its p-value, that is 0.48. So I fail to reject the null hypothesis of no co-integration. Similarly, if I check at most one co-integrating equation, I also fail to reject. So it means there is no co-integration. There is no co-integration. And similarly, on the basis of max eigen statistic, also for none that there is no co-integrating equation, so I cannot reject the null hypothesis. So it means that there is no co-integration. So when there is no co-integration, then I am not going to estimate vector error correction mechanism. Instead, I am going to estimate VAR model. So quick and VAR, and here I will keep it unrestricted VAR, and now I will write here my variables ly, lp, lm, li and le. These are 5 series, and I will keep these two legs, because on the basis of AKK information criteria and one other criteria, I decided that there should be 2 legs. Now when I press this, my estimated VAR model is this. You see, these are 5 series: log of real GDP, log of price levels, log of money supply, log of imports and log of exports. And in the rows, you see these are the lag values of these variables. That is lag 1 of ly, lag 2 of ly, then lag 1 of lp, lag 2 of lp, and so on. So these are the estimated equations, their standard error and their t values, and so on. And the r squared value is 0.99, adjusted r square is 0.995, and so on. Now this is the final equation that I estimated using vector autoregression. And let me also check some of the diagnostics of this model. So I will go to quick, to view, and under view first I can check residuals, and these are the various graphs of the residual. That is the residual of the ly, this is the residuals of the lp, these are the residuals of the li, these are the residuals of lm, and finally these are the residuals of le. So if you see, there are ups and downs in these variables, like in quarterly data. So you can just have an idea of how these residuals behave. I can also check the correlation matrix of these series, and this is the correlation matrix of these series. These values in the diagonal, these are equal to 1, because the correlation coefficient between ly and ly must be equal to 1. Similarly, the correlation coefficient between lp and lp must be equal to 1. So these values are perfectly positive correlated. But of the diagonal values shows the correlation coefficients between 2 different variables. That is, the correlation coefficient between lp and ly is minus 0.65, and the correlation coefficient between lm and ly is minus 0.03. The correlation coefficient between li and ly is 0.11, and so on. So you can see various correlation coefficients among various pairs of the 2 variables. I can also check the covariance matrix of these variables. So this is the covariance matrix of all these variables. Now I can also check some other diagnostics which are necessary and usually to see whether the model is good or not. So first of all, when I press view, then under view I will go to residual tests, and then under this residual test, first of all, I would like to go to autocorrelation LM tests. Now, when I press this, I again use 2 legs. So you see, sorry, I use 12 legs. So here I see that the null hypothesis is that there is no serial correlation among the residuals. So if I take 1 leg, the no serial correlation, the null hypothesis of no serial correlation cannot be rejected. Similarly, if I take 2 legs, the no serial correlation cannot be rejected. So if I see all these p values, I can see that there is no serial correlation at various legs except one, and that is when I take 4 legs. But since I have decided upon that there must be 2 legs, so at 2 legs there is no serial correlation. So serial correlation is not a problem in this model here. Now I can also check the heteroscedasticity of the variance. So for that I will use white test for heteroscedasticity, and if I press this, I get this. Now again, my null hypothesis is that there is no heteroscedasticity, no cross terms. So this is the giant test, the chi-square test. Its value is 315 and its p value is 0.25. So I fail to reject the null hypothesis of no heteroscedasticity. So both on serial autocorrelation and heteroscedasticity terms, this model is good. I can also check for the normality of the residuals, and this is the normality test. So let me use this Cholesky of covariance, and if I press this, now these are various tests: skewness, on the basis of skewness, on the basis of kurtosis, and on the basis of Jerk-Bera test. So this giant Jerk-Bera test value is 82.25 and its p value is very low, that is much lower than the 5%. So it means that the residuals do not follow normality. So there is problem of normality with the residual term, but on the basis of serial correlation LM test and white heteroscedasticity test, it showed that there is no serial correlation and no heteroscedasticity. We can also check some other diagnostics, but these are the very important ones that one can check with these models. And you can also check the stability of the model to decide upon whether your model is stable or not. So ladies and gentlemen, this is how we estimate, how we decide whether we should estimate vector error correction mechanism or whether we should use vector autoregression model, and then how to interpret and then check its various diagnostics like serial autocorrelation, heteroscedasticity, normality, stability of the model, and so on. Thank you very much for being with me. If you haven't yet subscribed to my channel, kindly do subscribe and click on the icon bell so that you can get notification when I will upload my other videos. Have a good day.